Okay, let's spend a few minutes going over how the tool works. So the first thing to notice is that the tool is served directly from GitHub. You have the link here. The same place where we develop the code. So you can track the development of the code and be sure to get a versioned serving of the tool to you. Of course, if you want to use an older version of the tool, you just have to use the corresponding version identifier from GitHub. So right at the beginning, you get the link for the live tool. Most GitHub users will know how to compose it, but you get it here, so it's easy to proceed. And then you go to the place where you probably got to this video, which is where the tool is served. So what I'll do is that I'm going to go through the different components of the user interface after exploring a few basic dynamics. So what you have here is the classification of a whole slide image, which is provided on the right. You can zoom in and zoom out at will. And the yellow in the image corresponds to deep learned cancer classification. The red corresponds to lymphocytes, so again deep learned lymphocyte classification, and the orange is the place where both classifications take place. You can click on any position in the image and go straight to the location in the whole slide original, where you can investigate further if the classification meets your understanding of what these classes should be. And of course T corresponds to the tissue. Now if I open the RGB, you'll be able to explore the way these synthetic images were assembled. So they're assembled from a PNG file, which you could get by clicking here. I'll give you a better way to get there in a minute. So these images encode for the deep learned classifications of tissue, cancer, and lymphocytes. And you get both the classification itself, so binary classification 0, 1, but you also get the probabilities. So let's go layer by layer. So this is the red channel, decoded, so that's why the image is not red. It's a number between 0 and 255 that is converted into a heat map, blue-red heat map. And you see that the lymphocytes appear to be on the edge of a structure. And that structure, of course, is the cancer. And again, you get the same information. So these heat maps correspond to a probability between 0 and 1 of the classification corresponding to this class, cancer on lymphocyte. And we'll have some tools where this segmentation can be explored. You can also see the original PNG, in this case with the segmented tissue. And you could go back to the classification. Now, when the first time you click on Advanced Tools, I'm going to push the image a little bit further. So the first time you click on Advanced Tools, you get a little animation of the two main features of going from classifications to probability distributions. Here we go. So you'll notice this is going to go blue here, as if you had clicked on it, and then back on classification, and you get the classification again. So hopefully this will remind you later that at any point you can click on background subtraction and get the probability distributions, or you can click on classification and go back. So when you're here, background classification, you can now see the exact probabilities for the deep learned classification. For instance, this would be cancer, and this would be lymphocytes. And see, you get the exact distribution you had before. The orange corresponds to places where the probability of both intersects, and so the classifications assign two classes to the same image patch in the whole slide image corresponding to this position. So let's click on it. There it is. We go straight. So let's put this back and let's do a little bit of segmentation. So the segmentation value itself, it's here between 0 and 1. So this segmentation of the probability. And here you can control the transparency of things that are segmented out. So let's go gently. So I'm going to move here. You see the line moving. You could say, well, it's not very clear. If it's not clear enough, you'd increase the transparency of what is segmented out, and this will become clearer. See, if you go do again, you see the segmentation progressing. Now let's imagine that as you do this, and we are segmenting the joint probabilities or the maximum of the two probabilities of classification as cancer or lymph for the corresponding image patches, you could say I'd like to see this happening in the classification provided here. So this would allow you to still segment the probabilities, but do it with a view of what the classes are expected to be. So if you like the way we generated these classes, you could make sure that your own distribution matches it. Now there is an interesting effect in the way we organize these interactive elements, which is that if I now remove cancer, without clicking on background subtraction, we'll be able to distinguish very clear where the cancer and the lymphocyte classifications are. See? So the blue now corresponds to things that were moved out of the lymphocyte classification, but had been classified as cancer. So everything that is blue corresponds to cancer, and the lymphocytes now appear more clearly at the edges of the cancer. Again, you can click on any of these components and go straight to the location from either place, from both the classification panel or from the probability distribution panel. Alright, so with this out of the way, you can of course now explore any image you want. And the segmentation values are preserved. Notice how now I open the advanced tab and we have no animation anymore. Let's reclassify. Let's get cancers back. There it is. Reclassify. See, we are back to the same panel we had before. This will take a little while to get used to, but if we did it right, you'll see there are many possibilities to explore these synthetic images as guides to the properties of different locations in the whole slide image. Okay, now let's go back to the original, to the panel of links here. So new window is, you can open a new window of the same tool. Especially if you have a big monitor, you may find useful to get several windows open on the same tissues or different tissues, and do these comparisons interactively with all of them open at the same time. This is a web application, so you should be able to open many versions of the tool in the same machine. Here you go back to the GitHub page. Issues is an important one. It allows you to give us feedback. So by clicking on it, the GitHub page will open the issues, and you'll be able to tell us any problems you may have or any issues you may want to resolve. And at some point, we'll also activate a Gitter chat box as soon as there is a little bit of a community, so you can also interact with other users of the tool and share experiences, tips, and so on. So we were at issues. Now dir. Dir, you get the directory of all the images being used in a way that can be served to your own application. So I'm going to click on it. So we are looking at breast. You have them all here. So I'm going to open one randomly. And so this image in the different layers of the PNG file has the classifications and the probabilities. And we should probably touch on that next. So before continuing to JSON, let's have a quick look at the classifications. So each PNG file encodes the deep learning classifications of the different image patches of a whole slide image. And the way this is encoded is that the red channel has the probabilities for lymphocyte classification, probabilities for cancer classification. You also get the original image, so you can compare them easily, and of course the classification itself. So this is for dir. You can of course get to the same image by clicking on the link here to be the exact same thing. And back. Let's see, where were we? Oh, dir, okay. So next is JSON. So if you're a developer, you may appreciate that the JSON file with the index of all the images, all the synthetic images provided with the tool are available to you here. Let's go back. And finally, of course, you have the YouTube video. So let's see if I forgot anything important. I did actually. I did forget to tell you about the tools that make it easier for you to share images with other people. So let's say you find an image you find interesting. I'm going to move to lymphocyte classification. You also can generate little movies. You can stop that. You'll discover some things as you go. So let's move this up a little bit. Okay. So let's say you find an image you want to share with someone. How would you do this? So I'm going to find some image. If we keep it on probability, let's say on the lymphocytes, you could even look for, this is just lymphocyte classification, so you could be running from one image to another and looking for places where the lymphocyte classification is substantial, for example. So let's go. So this one is quite a bit. Now let's say you want to share this image with someone else, and you can share it, the link to the tool that will be then rendered any way that the user wants. See, I'm moving the segmentation and the transparency and other things around in the way that explains why I'm excited about this image. So I may want to put the cancer back, for example. Now when you want to share, you just have to click here, and let me show you the URL, because something is going to happen there. So when you click on the link was copied, so it was generated here. You could copy paste here, but for your convenience, we also copy it to your clipboard. So if I now go to a new page or an existing page, it doesn't matter. If I paste the tool, the link, it will have the URL for the tool and then indication to which image it should proceed. There we go. So I give it a few seconds. So it generates the index, represents the first image, and quickly moves to the image you want to share. So you could now send this link by email or text, and potentially use the issues or the Git chatter to share your thoughts or your notes or your results with other people. So the same tool is now assembled for this image in another tab in another machine. Okay, hopefully I covered everything. If I didn't, again, please reach us either through issues or through the Git link that you'll find in the README file of GitHub, and I'll be happy to do my best to either advance the tool, explain how the tool works, or add new features. All right, thank you. Bye now.